All right, so next we're going to look at multiplying a matrix by its inverse and multiplying a matrix by the I matrix. Now, the product of a matrix and its inverse is the I matrix. The product of a matrix and its inverse is the I matrix. And the product of the product of a matrix and the I matrix is the original matrix. Guys, the I matrix here is called the identity matrix. Now, the identity matrix, the 2 by 2 identity matrix looks like this: 1, 0, 0, 1. So the identity matrix is a matrix in which all the leading diagonal elements are 1 and every other element in the matrix is a 0. So the leading diagonal elements are 1 and the other element are 1s and the other elements are 0. Now, multiplying by the I matrix is equivalent to multiplying by 1. So if I multiply a matrix if I multiply the matrix A by the I matrix, I'm going to get back A. All right. So that is important. That is actually something that we did in one of those earlier sessions. Example 10. Now, in example 10, this is the same matrices in example 9. So in example 9, we found the inverse of the matrix. So what I'm basically saying is that we're not going to do it. We're not going to find the inverse again. We're just going to use the inverse from example 9. It says in each of the following, show that the product of the matrix and its inverse is the I matrix. Now, I'm going to do B, then I want you to do A. Now, please note the version of the inverse that we're using is not the version that is where you have the elements which are fractions. We're using this version, the version before we multiply by 1 over the determinant. We're using that version of it. So let's multiply B by B inverse and see if we're going to get the I matrix. So B times B inverse, or B inverse times I. B inverse is 1 over minus 3 times the adjoint, 6 minus 2, 3 minus 3. So multiplying this now by B, which is minus 2, 3, 3, 6. All right, so the first thing we're going to do is we're going to multiply the two matrices, and then we're going to multiply by the fraction. So row by column, that's how you multiply two matrices. All right, let's erase this over to the right. Don't need this again. Erasing it for space. So when we're multiplying the two matrices, first element in the row by the first element in the column. So put the 1 over minus 3. First element in the row is 6 times the first element in the column minus 2. 6 times minus 2 is minus 12. And 3 times 3 is positive 9. All right, the same top row, the right column. So first element in the row 6 times the first element in the column 3. Oh, this should have been a negative. Here it should have been a negative. Good. So the first element in the row times the first element in the column, that's 6 times minus 3 is minus 18. And then the second element in the row 3 times the second element in the column 6, 3 times 6, that's 18. Now let's move to the bottom row. Bottom row, left column. Minus 3 times minus 2 is positive 6. Minus 2 times 3 is negative 6. Same bottom row, but next, the right column. Minus 3 times minus 3 is 9. Minus 2 times 6 is minus 12. So what we have is 1/3. 1 over minus 3, I should say. This is minus 3 here, 0 here, 0 here, and minus 3 here. So what we want to show is that when you multiply a matrix by its inverse, you're going to get the I matrix. Now, multiplying by 1 over minus 3 is the same as saying divide by minus 3. So this is minus 3 divided by minus 3, 0 divided by minus 3, 0 divided by minus 3, and minus 3 divided by minus 3. So what we end up with is 1, 0, 0, 1, and 1, 0, 0, 1 is the I matrix. So this is showing that if I multiply a matrix by its inverse, I'm going to get the I matrix. Please multiply A by A inverse to show that this is true. All right, so let's multiply A by A inverse and see what happens. So A inverse, using this version of A inverse, 1 over 2, where in which 2 is the determinant, the adjoint, 3, 2, minus 1, minus 4. That's A inverse times A, which is 2, 1, 4, 3. So this is a half, and let's multiply. 3 2s are 6. Minus 1 times 4 is minus 4. First element in the row 3 times first element in the column 1. 3 1s are 3. Minus 1 times 3 is minus 3. Bottom row, left column, minus 4 times 2 is minus 8. 2 times 4 is positive 8. Bottom row, right column, minus 4 times 1 is minus 4. And 2 times 3 is positive 6. So this is a half, 2, 0, 0, 2. Now, multiplying by a half is the same as saying divide by 2. So this is 2 over 2, 0 over 2, 0 over 2, 2 over 2, and this is equal to 1, 0, 0, 1, which is the I matrix. So what we need to remember from here is that whenever you multiply a matrix by its inverse, you get the I matrix. And when you multiply the I matrix by a matrix, you get back the matrix. Multiplying by the I matrix is the equivalent of multiplying an integer by 1. When you multiply an integer by 1, the integer remains the same. When you multiply a matrix by the I matrix, the matrix remains the same.